Hi all, myself Sreesha, Assistant Professor in ECE Department, Vedavyasa Institute of Technology. As a part of Techtalk series, today I am speaking about CUK-SEPIC hybrid converter. My topic contains introduction, objective, block diagram, circuit diagram, advantages, disadvantages and applications. The CUK-SEPIC converter is a converter topology for a hybrid solar wind system for extracting maximum power. This converter allows both the solar and wind sources to feed the load separately or combined together based on the accessibility. Thus, uninterrupted power is obtained. The characteristics feature of this system is that it provides uninterrupted and constant voltage to DC microgrid applications. Its main objectives are to provide regulated DC output voltage, to provide uninterrupted power supply, to reduce ripple currents, to provide power sharing, and to increase reliability. This is the block diagram of CUK-SEPIC hybrid converter. We can see that in this we can use different energy sources like wind, sunlight, etc. In this we use wind and solar energy. This wind energy is converted into alternating current by using a wind generator. The output of wind generator is AC, so a rectifier is used to convert AC to DC. Similarly, the solar energy is converted to DC by using PV array. These both outputs are given to the fused CUK-SEPIC converter. It provides uninterrupted DC supply. This is the circuit diagram of CUK-SEPIC hybrid converter. It contains both CUK and SEPIC converters. In this system, CUK and SEPIC converters are fused together to form a fused CUK-SEPIC converter. The diode of each converter are arranged and the output inductor and capacitors are shared between the two converters. This hybrid configuration permits the sources to feed the load individually or simultaneously based on its availability. This CUK-SEPIC converter is used for providing continuous power for DC microgrid. It has mainly 4 modes of operation. In mode 1, both sources are active. In this mode, both solar and wind systems are active for the generation of power. In this mode, switches M1 and M2 are on. Thus, the diodes D1 and D2 are in reverse biased condition. The supply voltage V1 and V2 charges the inductor L1 and L2 respectively. Also, the capacitors C1 and C2 starts discharging to charge inductor L0, which in turn charges the capacitor C0. In mode 2, only solar source is active. In this mode, only solar system is active for power generation. Switch M1 is on and switch M2 is off. Thus, diode D2 is in forward biased and D1 is in reverse biased condition. The inductor L1 is charged by the solar voltage V1. The capacitor C2 discharges through the diode D2 and charges the inductor L2. Capacitor C1 starts discharging and charges the inductor L0. In mode 3, only wind sources is active. In this mode, only wind system is active for power generation. In this mode, switch M2 is on while switch M1 is off. Diode D1 is in forward biased and D2 is in reverse biased condition. Thus, inductor L2 is charged by the wind voltage V2. The capacitor C1 discharges through the diode D1, thereby charges the inductor L1. Thus, the capacitor C2 discharges and charges the inductor L0. The last mode is both sources are inactive. In this mode, both the sources are not connected to the system for power generation. Thus, switches M1 and M2 are off. Diodes D1 and D2 are in forward biased condition. The inductor L1 discharges through the diode D1, due to which the capacitor C1 is charged. The inductor L2 discharges through the diode D2, thereby charging the capacitor C2. At the same time, inductor L0 discharges to charge the capacitor C0, thereby feeds the load R. This is the hardware setup of CUK-SEPIC hybrid converter. Its main advantages are it provides regulated DC output voltage at high efficiency, continuous power generation, reduced power ripple currents, reduced switching losses, simple structure and reduced converter components, supports wide range of PV and wind input, low input current distortion, improved conversion efficiency using P&O algorithm. Its main applications are this system finds applications in remote area power generation, constant speed and variable speed energy conversion system, aerospace industries, electric vehicles, communication equipment and rural electrification. I am going to conclusion. A CUK-SEPIC fused converter topology has been proposed for solar wind hybrid energy system. Two separate DC to DC converters are integrated together so that the count of components, size and complexity of the system is reduced. The proposed converter allows both the solar and wind sources to feed the load separately or combined together based on the accessibility. Thus, uninterrupted power is attained. Thank you.